Good day everyone. Welcome to massive open online course on cartographic techniques. Today we will learn about dot maps and flow maps and how to create dot maps and flow maps using open source geographic system software. So this is the content overview of what we are going to learn today. First we will see what's a dot map and its characteristics. Then we will move on to flow maps. What is flow maps? What are the advantages of using flow maps and its characteristics? Then we will move on to practicals. We will create few dot maps and flow maps using open source GIS softwares. So first, what is a dot map? A dot map is used to represent a fixed quantity of data. Let's say for example population density, or a disease spread, or agriculture production, or crime mapping. All this quantitative data we can represent using dot maps. Its advantages: it's easy to visualize patterns of the disease outbreaks, or let's say the agriculture production. We can easily determine the trend. It's easy to interpret compared to choropleth maps. So these are the few characteristics of dot map. Each dot represent a specific value. Let's say we are creating dot map for population density. So there one dot may represent 1000 people or 10,000 people depending on the population and the population density which we are keeping on the dot map. Dots are placed randomly within the area but represents actual distribution. It's useful for non-uniform data distribution visualization. It must be chosen carefully to avoid overcrowding or sparsity. Next, we'll move on to flow maps. A flow map is used to visualize the movement of people, goods, information between places. We can use flow maps and show both the direction and magnitude of the flow. It is used to create maps of migration routes, trade flow, traffic movement. The few characteristics of flow maps is we can see the routes of how the travel or trade is happening, and we can use arrows to show the directions, and to show the magnitudes we can use change the thickness of line accordingly to show the magnitudes. Now we will jump on to the software. I will open QGIS in the system. We will create a new project. So here, to open shapefile, we will select India states underscore population dot shp. I will select this shp, drag and drop to my working window of QGIS, and we will minimize this. See, this is our India map. Here we will go to attribute table. So here we have the name of states, total population male and total population female. Okay, so we have the population data with us. We will go to plugins. We will install a plugin for dot map. Maybe sometime the plugin may be buggy. So if in this case also it's like that, we will go with some alternate tool. So dot map, install plugin. So now the plugin has been installed. We go to vector, dot map, dot density map. We will select the polygon layer and the integer field, select total population. So this is the minimum and maximum value. So how much our one dot should represent, we will give it in this field, number of elements by dot. So if we give 1000 over here, this means our one dot will represent 1000 population, 1000 people. Okay. So I am giving 10,000 simulation. So this is the minimum value 6 and maximum 19,981. See, input can only be in number. So what we will do is go here, open attribute table, see if we can check the total population is already an integer value. We can see here, right? Here we can see the total population is already an integer value. Still we are getting this error. Still it's showing us numbers can only be in integer, correct? So maybe there will be some bug with the plugin. So what we'll do is, input can only be number. So we'll use a native tool for this. In processing toolbox, we'll search for random points and polygons. We'll open this tool. So here we can see, right, here there's a small arrow over here, and the distance here is in, there's a error beyond your, here we can see a error symbol, right. This is because the map projection is in WGS 84. So we'll change the projection first. We'll come here, processing toolbox, reproject layer. So the first one is for point cloud data. Okay, here if we see, the first reproject is for under point cloud layer, so we won't be using this. We'll use the reproject layer which is available for vector file. Okay, so we are working with vector file. We'll choose the tool available for vector file. So here we'll come to reproject layer. Run. Recently used tools. Okay. Random points and polygons. Okay, we'll select this number of point for each feature. Here you can see a arrow symbol over here, right. Here there's a small arrow symbol. We'll click on this arrow symbol. Here there is an option called assistant. We'll come to this assistant tab, open it. Here number of point for each feature, source. We'll take this population density. So first we'll check how much, what is the data over there, open attribute table. So the maximum value is 11,000, correct, 11,162. So we'll keep the values from 0 to 12,000. We'll refresh this first. So yes, it has taken the minimum and maximum value. The same we will keep for output as well. Now we can see that each population for the specific state has been represented by the dot. So as the dots and the background of the shapefile both are in dark colors, it's not highlighted. So what we'll do is we'll change the base color from red to subtle yellow. Okay, apply. Okay, so if we zoom in, so here we can see, right, the population has been plotted as dot. Each dot represents 1000 people. So this is how we create a dot map. So let's say now we have the shapefile with us and we are downloading the population data from census data or some other source. So how we can link those data with our shapefiles, that we'll have a look at now. So first I'll remove all these layers which are with us. See, and before that, here next to our layers we can see a small icon over here, correct. This icon represents that these files are temporary layer. So once we close our QGIS window, it won't be saved, it will be getting deleted. So if we close with a file project with temporary layers, to show this project includes one or more temporary layers, these are not saved in your disk. So once you close this, this will be permanently lost. So if we want to save this, what we'll do is right click, export, save feature as, go to file browser where we want to save, point density, save, click OK. Now this file has been saved. We'll remove this now, remove. Okay, so now I have downloaded population data from census data in Excel sheet, and I have segregated the population data for Tamil Nadu districts. Okay. So similarly, from India's shapefile, we'll segregate Tamil Nadu's shapefile. So I'll go to India admin. So administrative level boundaries, your admin level 0 represents your country level shapefile, and admin level 1 is for state level shapefiles, and admin level 2 is for district level, and level 3 is for sub district level. So we will open this India admin level 2. So now we will go to attribute table. From here we will select the districts of Tamil Nadu. So here come to Kerala. So we are selecting all the attributes of Tamil Nadu. Now in our map, if we see, all the districts of Tamil Nadu is being highlighted, correct? So now we have selected it. What we will do is again come to layers panel, right click, export. This time export save selected features as. So whatever we have selected, all those features will be getting saved. Browse for file location. Tamil Nadu with districts. Okay. So we don't need these other layers, right? So we'll remove this. Okay, remove. Okay, remove from legend. Okay, this I'll hide it. So now we have the shapefile, and we have this population information in a separate Excel sheet. Now we want to link this Excel sheet with our shapefile, correct? So we'll have this Excel sheet in a CSV format. If it's an Excel format, just convert save as CSV. Then what we'll do is we'll go to layer, add delimited text layer, browse for the file. So here in geometric definition, we don't have latitude, longitude, right? So we'll go with no geometry. Okay, so we don't have coordinates, we just have the district name and the population. So we'll go with no geometry, add, close. So here we can see the table has got added, right? So now we have the population data and the shapefile with us. We want to link both. So what we'll do is we'll come to the shapefile, right click, go to properties. Here we can see an option called joins, right? We'll come to this joins. Here there's a plus symbol, correct? We'll go on this plus symbol. Which layer we want to join? Here we can select which layer we want to join. We'll select the layer from here and which field we want to merge. So to link two files, one shapefile and the Excel sheet, we need to have one column between them common. So we'll just check that once. So here if we open the shape file, we have the district names in name 2 and it has a unique ID 459, 450, 451 and so on, correct. So same way in the Excel sheet what we have done is we have already created the ID. So according to the district name we have matched the ID. So now we will join both the layers comparing the ID. So ID for Chennai is 450 in both the cases. So either we can use district name or ID to match both the layers. Again we will go to properties, joins, join layer, Tamil Nadu population, join field ID, target field ID 2. Okay, so in Tamil Nadu shapefile it was in ID 2, right? Yes. Okay. So this layer has got join, apply. Okay. Open attribute table. Now here we can see the population data as well, right, which was there in the Excel sheet has got merged in our Tamil Nadu shapefile as well. So again we will go to random points and polygons, Tamil Nadu with districts, yes. So we will click on this small arrow icon over here, it's not visible, I will just highlight that again. Here is one small arrow icon. So you click on this and go to assistant tab, source, this time we will create for male population. We will click on this refresh button, it will fetch those values. So this is the total population. If we want population density, we will divide it by area, or if our dot wants to represent per 1000 male, what we will do is with the value we will divide it by 1000. Showing expression is invalid. Check in attribute table, open attribute table. Check. Okay, so before that we will export this complete thing as a shape file. So export save feature as file name. Okay, I will remove this. Again we will go to assistant tab, source, this is total population, divide by 1000. Yes. So last time what happened was our data was linked and it was not in our shapefile, right? So we will save it as a shapefile and we will do the operation again. So this time this is the total population, we are dividing it by 1000 so that our each dot represent 1000 of people. So the value will range from 565 to 4646. So instead of 1000 we will make it 10,000. So each of our dot will represent 10,000 of the population. So now we will run this. So when we have run this, so it has come as a temporary layer, as you can see this icon over here. So if we want, we will save it, export, save feature as population density Tamil Nadu. Okay. Okay, next we will move to flow maps. So this is how dot density map is created. Move legend. Okay, we'll remove this. Now for flow maps, what we'll do is we'll take on some open source airport data and we'll create flow of flights. So for that we'll go to our browser first. We'll search for open airports CSV. So the very first link, openairports.com, we'll go here, and in a CSV file we'll be getting the details about all the airports which are there in the world. We'll open this. It will be getting downloaded. Yes, we have downloaded the airport CSV file, so it's in the downloads folder, correct. We'll come to our QGIS again, layer, add delimited text layer, browse the file, airports.csv, add, close, layer, add layer. So now this time we have the latitude and longitude of the file, correct. So in file format we'll select CSV, and in geometry and definition we'll make it as point coordinates. Now x is longitude, y is latitude, it has detected it automatically. Now we come down, we click on add. Now we can see all the airport has been plotted. Here all the airports are the small scale, large scale, and even the helipads are there in this data. We'll segregate the data which we need. So first I'll just turn this on. We'll be doing the analysis only for India. So we will be selecting the airports which are only available in India. For that what we will do is, first this is a CSV file, correct. So we can't do much of the GIS operation on top of CSV file. So we need to convert it into a shape file. Right click on the airports file, export, save feature as airports, save. Okay. Now we will remove the CSV file as we have the shape file for the same. So now to select the airports which are only in India, what we will do is we will search for clip tool. What this tool will does is it will clip out the airports in India from the total airports. So as this is a vector file, we will be selecting clip under vector operations. So the first clip is for point cloud data. We will be selecting the clip under vector operations, clip, airports layer, overlay with India shapefile. So whichever airports are overlaying on top of India will be getting clip. Here we can give the file destination folder where we want to save it. If we leave this blank, it will be creating as an empty layer. We will run this. As we can see now, the airports in India has got clip. So if we turn off the layer, total airports, see this clip data is the airports which are available in India. So we will remove this airports too now. So now we will open this clip data, open attribute table, and we will check this data once before starting working with it. So yes, So from this, so what all closed airports are there, we will remove it from the attribute table. We will delete it from our selection. So first, toggle editing. Once the selection is made, here there is an option to delete selected features. Delete 30 features. Again we will go to attribute table. We will remove the heliports also. We'll select all the heliports. We will only keep large airports and medium airports and remove all other data. Okay, so we have segregated the large airports and medium airports. Now we will save this clipped file. So this is a temporary layer now. We'll do right click, export, save feature as. Airports in India. Okay, we'll remove this temporary layer. Remove. We'll keep a subtle color for the background. Symbology. Now we will see flow of flights from Mumbai airport to rest of the airports in the country. So for that we need to install a tool. We need to install a plugin called shapes. So we'll go to plugins, install plugins. We'll search for shape. So here we can find shape tools, right? Shape tools. We'll install this. The shape tools we will use to create the transportation lines, the flight routes lines. Shape tool is a collection of geodetic shapes. Now we'll open the attribute table again. So first we'll see what shape files is. Vectors, shape tools, create line. So here xy to line. So here what data is needed is, we need the start point and the end point, the latitude and longitude of start point and the ending latitude and longitude. Okay, to create the path we need the start point and the end point. So for that we need to have the source latitude longitude and the destination latitude longitude in our attribute table to work with. Okay, so as we are doing it for Mumbai airport, so source will be Mumbai. So we will be checking the traffic from Mumbai airport to rest other airports. So the source airport is Mumbai. So we will select the airport in Mumbai. We will take the selection tool, select. So here we can check the ID 26444, correct? So here is Chhatrapati Shivaji International Airport 26434. So 26434. So this is the source latitude and source longitude. So we need to have the source latitude and longitude in all the attribute tables. So what we'll do is, we'll copy this latitude value, we'll edit this table first, copy this value, and we'll add a new field for source latitude and source longitude. Add new field, source latitude, decimal number, I'll change the precision. So here we have, here we can write an expression and update our table, okay, just like our Excel sheet. How we write formulas in our Excel sheet, we'll come to the source latitude, we'll paste the value which we have just copied, and we'll update it in all the fields. Okay, update all. So as we scroll horizontally, here we can see source latitude has been updated in all the fields for all the spatial entities which we have. So similarly, we will be doing for longitude as well. So now I will copy the longitude. Here we will create a new field for longitude. Here we will select our source longitude. We will update the value with the longitude value of Mumbai. So I will copy this, copy, paste, update all. So we have updated the source latitude and source longitude, and the destination latitude and longitude we have it by default over here, correct? We'll save this attribute table first, close it, and go back to our tool again, XY. So now input layer is our airport data. Our starting longitude is source longitude and latitude is source latitude, longitude, and again latitude. Yes. First we will create it as a temporary layer first, run. Maybe there is some error with the latitude and longitude values. Open attribute table. So here we can see the longitude values. 1 second, I'll just edit this. So here we have error with our longitude value, source longitude. So we'll just change it, update all. I'll check it again. Yes, now it's correct. Save. We'll again create the lines. It's not getting copied correctly. I'll open this attribute table again. 0.86. copy, go to longitude, yes, update all, save. Yes, this time the longitude is correct. Okay, XY, starting field source lat, starting field source longitude, source latitude, we can see the traffic from Mumbai airport to rest other airports in the country, correct. Now we can, as we have already learned about colors and symbology, we can gradually change the thickness of this lines based on the altitudes on which the flights is flying. Okay, so as this layer is already being selected, so we are getting it highlighted in red. So we will go back to the attribute table, we will deselect this, yes, close. So this is how we create a flow map. If we want, we can add a base map of Google hybrid map to behind this, yes, and how we can change the properties and colors, symbology, everything we'll meet in the upcoming session. Thank you so much everyone.